Have you ever wondered what life without GPS would look like? It could start with some minor nuisances. You cannot find your favorite coffee shop in a new city. The Uber cannot find you. Or you don't know which exit to take on the freeway. But things could start escalating very quickly. We will have chaos at airports. We will have disarray in the sea. And emergency responders may not be able to find where their call is coming from. You may wonder, is this sci-fi? Well, things would get even worse with autonomous vehicles. Self-driving cars will start crashing into each other. Drones will start coming down on our heads from the sky. And we are now dependent on intelligent vehicles to farm our lands. Well, those will not know where they are, and they will start crashing into trees. You may wonder, why would this happen? Why would we lose GPS? The most obvious reason is war zones. So there is jamming and spoofing of GPS. One causes you to lose the signal. The other one tells you you are somewhere where you are not. And that's what happened to this poor Azerbaijan Airlines about a year ago, where it entered the wrong airspace. Someone convinced it was elsewhere, and the Russians shot it down, and lives were lost. And not too long ago, oil tankers collided in the Strait of Hormuz in the Persian Gulf during the Iran-Israel war for the same reason. And no one is safe. International conflicts, unfortunately, around the world are happening more and more. Even the chief of the European Union had to undergo emergency landing in Bulgaria because it's suspected that the Russians hit it with GPS jamming. Terrorism is another reason. It already happened in India. And of course, organized crime are starting to capitalize on it, from truck hacking to drug trafficking in the by the US-Mexico border, to even illegal fishing and sea activity in the sea. Or it could be completely unintentional. And there was a famous story where a truck driver had installed what you call a personal privacy device. It's illegal, but you can buy it online. Put it on his truck so not to let his boss know where he was going. Little he know, he was driving by Newark Liberty International Airport every morning, and he would cause disruption at the airport. The same story happened a couple years ago in Denver International Airport, which caused parts of the runways to be shut down. Now, the message I'm trying to get you to believe in today is that of hope. That airline that had fallen down could have averted that destiny if it had looked up at the stars. And those are not God-made stars, those are man-made stars. So those are the thousands of low Earth orbit satellites that we are launching into space, of course, led by no one but SpaceX's Starlink. So far, they had launched more than 10,000 satellites. The second closest is OneWeb constellation, that's a European constellation, but Amazon Leo will launch thousands. The Chinese, of course, it's a space race, so they are planning to launch tens of thousands soon. So those satellites offer us a lot of wonderful opportunity to avoid that life that I scared you about earlier on. First of all, we will have many, many satellites, so why don't we use them? In 2019, there were about 2,400 satellites in LEO. You compare that to poor GPS and its sisters. Of course, the Russians have a system that's equivalent, the Europeans have, and the Chinese have. Collectively, we call them GNSS, Global Navigation Satellite System. We have only 84 of those. By 2026, we're already at 11,000 in LEO, 125 in GNSS, and by 2029, we will get to 60,000 satellites. Think of that. Those satellites are much closer to Earth compared to GPS, so they're about 20 times closer to Earth. So we're going to get about 1,000 times stronger signal. All of GNSS satellites transmit in a small sliver of the spectrum. If you look at GNSS, they transmit at a much wider swath, from the VHF all the way to the Ka band. And finally, I'm a cheap guy. If something is free, I love it. Those signals are free. We can use them. So that's what we are trying to do with those signals. But of course, according to what I told my students, the no free lunch theorem, there is no free lunch. We have to solve some challenges, research challenges, that the first is, what the heck do they transmit? The signals are mysterious and proprietary. They don't tell us. We have to figure that out. What is their time? What's the time on the satellite? We don't know that either. We have to resolve atmospheric errors as the signal propagates through the ionosphere and the troposphere. And where are these stars? The best public knowledge is erroneous to within kilometers. That's not enough to know where you are within meters. So we will have to solve all of that. So that brings me to my lab, the Autonomous Systems Perception, Intelligence, and Navigation. And those are my students, current and past, that have been looking at these questions over the years. And the way we think of this world is this trinity. You have three segments. The first one is the space segment. We don't worry about that. Let them launch their satellites, and we will drink their milkshake. But we will develop our own user segment. We will develop the receivers that go on boats, on planes, on cars, in your phone, and we will develop the ground segment, which will crowdsource the signals and share information with those users. So let me show you real quick how we solve the user segment and the ground segment. So first, for the signals, what do they transmit? We took inspiration from nature. This is a pulsar. It's a fast spinning star that transmits a pulse like a lighthouse. So we developed algorithms in my lab that allowed us to treat those as beacons and decipher the signal, no matter who is transmitting what. And what you are seeing here are different beacons from different satellite providers. Now, for the second problem, we need to know the time on the satellite, and we need to know where the satellite is in space. So let's roll our sleeves and go through the math. I'm just kidding. So this is the work. This is the work of two of my superstar PhD students that have been studying this. But what I will show you is what we were able to do with this. First of all, it got lots of publicity around the world, from Science reporting it to very recently, it appeared on the main webpage of Ohio State, IEEE Spectrum. That's a very well-respected venue for technical content. Appeared on many, many magazine covers from 2019 all the way through 2026. I also presented this work on Capitol Hill, in the Pentagon, in think tanks in Washington, D.C., at the University, at the U.S. Department of Transportation headquarters, and at international conferences. But let me now show you how the world could become a better place without GPS. So I'll take you through a journey, land, air, the stratosphere, and the Arctic seas. And I'll show you how we were able to navigate with Starlink across the US and even Greenland. First, let's go to Pittsburgh, where we navigated this ground vehicle. We set up a base station in Columbus that listens to the satellites and started communicating some data to the car that's driving down the freeway in Pittsburgh. And red is what you have today if you lose GPS. You can't even see it anymore because you will be lost. Whereas in green, which follows very closely the blue is how the car is traveling, and the green is what our system is able to produce. Very, very close to how the car is traveling, completely without GPS. We went down from errors of about 650 meters down to about 8.6 meters. Remember, we don't know what the signals look like, and we don't know where the satellites are in space exactly. Now let me take you back to Columbus, Ohio. We set up our reference base station in the electroscience lab, not too far from the SHU. And then the students set up this drone last summer, and was the first time anyone had shown a drone flying with Starlink. This is in Tuttle Park, and you can see very cheap hardware is what we are using. All of the smarts really is in the algorithms that we develop. Somehow a rogue RC car decided to intrude, but it was too late. The Eagle had taken off. What you are seeing in red, it's a $15,000 device that is a navigation device, but I'm showing you how that device will behave without GPS. It will not even know where the drone is. So the drone will not know where it is, whereas in green is what we are able to estimate using those Starlink satellites. Next up, we decided to go even higher. So we called this mission Icarus, after Greek mythology, who flew too high, close to the sun, but ended up melting and dying. Thankfully, that didn't happen to us, otherwise I will not be here. But we did that in New Mexico. We worked with Sandia National Labs. We put Brutus in the payload that we are going to fly this high-altitude balloon. There were 3 Buckeyes, so we did the OHIO, but the balloon was the O. Some push-ups on the runway. We were all pumped up. Took us a year to design this payload. It went to 83,000 feet. That's more than twice how high commercial airlines fly. We recovered the balloon. We had to fight with Bibo from UT Austin. We ultimately recovered, I went to UT for my PhD, so I can say that. Anyway, so we recovered the balloon, we processed the data, and that's the success story. You see in red, if you lose GPS on that balloon, whereas in green, using Starlink signals, we are able to estimate where the balloon was. And thankfully, you didn't hear about us in the news like a couple of years ago when we had these balloons flying over the US. So that's a nightmare I kept having. Finally, Greenland was in the news a lot, so we decided, why don't we go to Greenland and see, can we navigate in the Arctic, a vessel? Of course, we had to send Brutus to check it out. We asked the crew to do the OHIO for us. This is the Adventure Canada vessel that navigated in the Arctic. And the idea is, this is our collaborator who collected the signals for us, pretending, well, the world is beautiful. I have GPS, I know where I am. But GPS starts acting weird, and there are reasons why it would act weird there, if you know what I mean. So here we are going to borrow some footage from a movie called Adrift, where they got hit by a storm. And really, this is what you will experience if you are hit by GPS interference, jamming, or spoofing. It is an electronic storm, and you will be lost in the Arctic. And of course, you don't want that fate. Thankfully, she happens to have our hardware. She takes it out. Does anyone copy? And to our surprise, pleasant surprise, I should say, Starlink and OneWeb were transmitting over the Arctic. We used their signal, and we showed if you lose GPS, that's where you will be. You will be adrift in the sea, whereas in green, that's what we can estimate. So we go down from being lost by a kilometer down to about 27 meters. I hope you will never experience this in your life. I hope you will never live a day without GPS and be in such misery. I hope your life will look more like this. You're driving down the street. You're not even looking at your car because it's driving itself. But when your car suddenly shows no GPS, you will know that that's no problem because you have Leo, and that's how the car will drive itself. But when you see this happen, that it started here in Ohio State. Thank you.